Welcome all participants. Program will be started in next 5 minutes. Please invite your friends who have registered for this program. At 7 o'clock, we are going to start the program. Please invite your friends. Welcome all participants. Within 5 minutes, we are going to start the program. Please invite your friends. Today, we are going to see the basics of computer vision and various projects using these computer vision libraries. Within 2 minutes, we are going to start the program. Please invite your friends. Within a minute, we are going to start the program. Please invite your friends. Hello all, myself Sai Satish, President of AIMERS Society. So what is this AIMERS Society and what's the purpose of this society? So let me introduce for a minute about this AIMERS Society. Today, you already know it's third wave running in our country, India, right? So in first wave itself, I thought to integrate the engineering and medical domain. I want to bring these two domains under one roof. At that time, I thought a lot. And then I thought to establish a kind of platform for both medicos as well as for engineers. When I think about this particular situation, most of the medical domain are not great techies when compared with engineers. Okay, when compared with engineers, when engineers don't have great medical knowledge when compared with doctors, that's obvious because they have studied, they have invested a lot of time on studying these subjects. So what I thought was if we could bring both medicos as well as engineers under one roof and using AI, if we add some sort of AI to the technology, we can achieve great things. So we started this particular society called AIMER, Artificial Intelligence, Medical and Engineering Researchers Society. For this, we need your help. What kind of help? You have to do a lot of research and you have to assess the medical domain. For that, we are bringing various kind of programs related to artificial intelligence. We train you on AI, how to use this AI, what is this computer vision, how medical devices work. We train you on all these things. Okay. Your job is to help the medical domain in achieving great things. For example, if you take mortality rate in our country, out of every 1,000 births, 30 infants are dying within a year. 30 infants without proper reason. If we could make a device which can speak infants' language, infants cannot speak our native language like Tamil, Telugu, or Hindi, right? So if you could make a device which can understand infants' language, that will be great. So we have to bring such type of creative ideas and we have to make them real. So that's the main purpose why we have created this researcher society, especially for doing research on medical domain. Okay. So coming to today's program, today we are going to have a workshop on computer vision from basics. Prerequisite for this computer vision program is Python. You should know the basics of Python, then you can understand this computer vision very easily. In our society right now, few engineering colleges and couple of universities become institution member like CMR Technical Campus Hyderabad, NRI Institute Agripalli, Narayana Engineering College Gudur, BVRIT Women's Hyderabad. Like this, few universities and engineering colleges, including VR Siddhartha Engineering College at Vijayawada, few engineering colleges already associated with us, few hospitals also associated with us related to ophthalmology, ortho, various medical hospitals and medicos also associated in our society. So the main target of our society is to do, our AIMER society is to do research on medical domain. So most of the engineering students are joining in this today's program. Around 2,000 people registered for this program. And since this is live streaming in YouTube, it will be there forever. Most of them will watch this video and they will work for a cause. I believe in it. Okay. So what is the purpose of this computer vision? See, computer vision means giving eye for your computers. If you lock your phone with the help of face detection, it's getting unlocked, right? It's also a computer vision program. We are giving an eye for our computer program. So how this computer vision works and how to make it to work, that's the ultimate target. Even central government is also encouraging a lot of these kind of programs. For example, if you take this particular contest, if you have a great program related to computer vision, they'll fund you. Central government, STPI. This is one of the old contests. That means 1 year back contest. Every year, STPI is organizing a contest on computer vision. Computer vision. Most of the robotics industry highly depend on this computer vision. For example, if you take autonomous cars, that's also a computer vision application. Not just one or two, most of the AI-based robotics are working on computer vision. Let me show you a small video with some robots. All these robots, almost 80% of robots are example of computer vision. Just pay attention for 2 minutes, 3 minutes. Then we are going to start how to play with these kind of activities using computer vision library. Today and tomorrow, both the days, we are going to discuss about computer vision. Tomorrow, we are going to see how to develop simple projects using computer vision library. Today, we are going to see the basics of computer vision. Okay. Tomorrow, we are going to see how to make projects using computer vision library. Okay. Just see these robots. Fantastic, right? See the accuracy of the robot. These are the examples of computer vision. So how many of you like this kind of robotics? Most of these robots are having or using computer vision. Got it? You can use these kind of computer vision libraries to pack the things, pack some sort of products, to navigate not just one or two applications, some hundreds of applications you can make with the help of this computer vision. Hardly if you could invest few hours of your time, you can make such type of products. Tomorrow, we are going to see at least 5 different kind of projects with source code. Okay, so let me repeat. AIMERS Society is a non-profit organization which aim to do research on medical domain using AI. So for this, we train you on different kind of subjects related to AI. One of the subjects is computer vision. So we'll connect forever in the groups. Most of you already joined in our WhatsApp group. If you have not joined, I'll share Telegram group also. You can join in Telegram group. Tomorrow I'll share some more WhatsApp groups. If you are not in WhatsApp group, please join the WhatsApp group so that our future programs related to AI will be shared to you. Let me repeat for before starting the program, the content. Let me repeat. Our existing members as of now are CMR Technical Campus, Hyderabad, NRI Engineering College, Institute of Technology, Agripalli, Via Siddhartha Engineering College, Narayana Engineering College, Gudur, BVRIT Women's Hyderabad. Thank you for all institution members. Most of you are from that particular college, and some engineering colleges, especially from Dr. Patil Engineering College, also joined with us. Tomorrow, I'll show you the list of various engineering colleges. Thank you very much, Patil College students, for joining. Plenty of students are from that particular college, many students. Few are from IIT Hyderabad. I'll share some of the engineering college names tomorrow, those who joined as a participants for this particular program. So one of our presenter, Mr. Vishwanath, is here. So Vishwanath will be presenting on this particular topic. The basics of computer vision will be started today. If you know the basics of Python, it's enough to start getting with computer vision. Exactly pay attention for 40 to 50 minutes. You'll get the overview of this computer vision, and you can start simple programs from today itself. Over to you, Vishwanath.
Okay, sir. I hope you can hear me well, sir. My
Yes,
voice is, I hope. Okay. So, hello, good evening to everyone who's in the YouTube live now. So welcome to this AIMERS workshop on OpenCV. So my name is Vishwanath Hemant from Indian Servers. So today I'm going to be, explaining a little bit about, giving you a little insight into what OpenCV is, what it stands for, what you can do with it. Okay, what is the purpose it was created, and I'll also show you a little bit, coding into with Python on OpenCV. Okay, we'll do some image manipulations and all. Okay. You'll understand how these filters in your favorite social media apps are made. Okay, how does a image editor work? Okay, for today we're just sticking with images and how to manipulate them, because we're just starting. Tomorrow you'll see different projects, very interesting projects. Okay, you'll be shocked like how easily you can do them. Most of them you'll think, I mean, if you see them without any context, you'll think, okay, it's some big project, it's something we wouldn't understand. But we'll show you with coding and all, and you'll feel it that it's a very simple one. Okay, so what is this OpenCV? Let me share the screen. So actually, participant screen share is disabled. Can you make me co-host, sir?
Sure.
Yeah. Okay. Yeah. So this is the official website of OpenCV. OpenCV stands for Open Source Computer Vision. Okay, computer vision has been there since a long time. Okay, you may have seen like many places, even in in traffic. People say that there are cameras and they automatically give you fine if you're not wearing a mask or not wearing a helmet. Okay, those are all computer vision applications in your colleges. Since most of you are from different engineering colleges, mostly faculty, they'll have a photo biometric system for attendance, like at what time they attended the college, at what time they're leaving the college. Okay, those are all computer vision, and various other things are also there. I'll give a little examples just a bit after this. So, but what is this OpenCV? If computer vision has been sticking around for a long time, what is this OpenCV? This OpenCV is open source for everyone, so that everyone can create their own open source, sorry, computer vision applications. Okay, real time computer vision applications. Okay, so this is an this is a cross-platform library. This OpenCV is a cross-platform library. As you can see, it works on different platforms like all the desktops, even Android, iOS, and all the mobile platforms also. So this is a library in which we can develop real-time computer vision applications. So what is this real time? Okay, just like the examples I've told before, they are all real-time applications. And so what is computer vision? What defines computer vision? Like just before Sai Satish said, this OpenCV is the eye of the computer. I say this is not just the eye of the computer. This is also a kind of a brain to the computer. Okay, not see, camera is the eye of the computer. Well, OpenCV is the brain of the computer. Okay, so what defines this computer vision? Okay, what is the difference between just taking images and processing them and computer vision? Okay, computer vision defines, it explains how to reconstruct, interpret, and describe images, and to understand these 3D scenes. Okay, 3D worlds that we live in through 2D images, right? So you have seen some videos before, robots doing different things, playing baseball, playing bowling, different sports and different activities they're doing. So how do they do that? We know that they do that with computer vision. Okay, even we have only vision only. So if we are interacting in this 3D world, we are not doing that through some sensors or something. We only see through eyes. We only get 2D images only, right? Whatever we see is 2D image that is projected on our retina, right? We don't have any radars that send sound signals or other frequencies and they return back, like bats do. Okay, we only see 2D images, but we interpret the 3D world. Okay, the same thing we are emulating for a machine. Okay, we are taking 2D images and describing how to interpret the 3D worlds, right? So how does it do that? Okay, so we understood that it takes 2D images and describes the 3D world, but how does it do that? This computer vision mainly, significantly, what should I say, intervenes with these three domains, right? One is image processing. What is image processing? Image processing is just manipulating different images. You take images and apply different filters, apply canniness to it. Okay, basically changing images to whatever you want. Okay, getting whatever you want out of images. And the second thing is pattern recognition. Okay, so we see, when we see the outside world, we can at an instant identify whatever is in front of us. If it's a just let's say like there's a laptop in front of me, I can identify it. If there's a person in front of me, I can identify them. How? Because I understand the patterns. Okay, so laptop is something which has two rectangles. It folds in a way. Okay, how does my brain understand that it's a laptop? It has a pattern for a laptop. So once I've been shown one laptop, I can identify different types of laptops, right? Like that. In the same way, persons also. That's pattern recognition. And the third most important thing is this thing called photogrammetry. Let me just write them for you. Let's open up Notepad. One is image processing. Second one is pattern recognition. And the third one is photogrammetry. What is this photogrammetry? This is the most important one. Photogrammetry is, it is concerned with obtaining accurate measurements from images. Okay, so I've seen this, this one iOS app. I'm sure it's in Android also. This app where you can open up your camera. Okay, you can place virtual points on your real world. Let's say you can measure stuff. Okay, I've tried it. I opened up the camera and set up virtual points on my table. Okay. Okay. Yeah. Right. So I opened up the camera and check use that app and set up virtual points on my table. Okay, what it does is you can just open up your camera. It'll measure whatever thing you want to measure, right? Okay, you have to just set up virtual points in between there. So when I measured it, it was on point. Even it did not even go 1 centimeter wrong. It was just on point. So this is the magic of photogrammetry, right? So getting accurate measurements from images. Okay, so the one video you have seen before, a robot was jumping from a higher position into a pool of balls, and one robot was feeding the cat. So how does it, how does the robot calculate the exact distance? Okay, so having different types of sensors that shoot waves of sound waves or so, it is easier thing. Okay, it can give accurate results, but it takes a lot of energy. Okay, but in case of a photo, okay, it consumes very low power. And if we can get very accurate measurements with by looking at images, it would be a big win for everyone, right? So yeah, that photogrammetry is there. And coming to the applications of this computer vision, I think it's important for you to know where these the computer vision is applied. You have seen a lot of robots before, in the previous video, but there are other applications also, not just robotics. So in case of robots, there is navigation, object detection to avoid colliding. Okay, there are humanoid robots that move around in your space. Okay, they do not collide with anything, but because they have this object obstacle avoidance feature. Okay, it is also achieved through computer vision only. And one of the main thing that this AIMERS society should address is the medical applications, right? So like medicos are also literally half the part of AIMERS, because so it's important that you need to know what are the medical applications in this using this computer vision, right? So using the computer vision and machine learning and deep learning, okay, machine learning and deep learning along with the computer vision, we have made models. I mean, not we, but the humanity has made different, what should I say, models or machines that can see and understand different X-rays, MRIs, okay, magnetic resonance images, okay, all of these, and they can classify. They've been classifying different types of tumor and cancerous cells. Okay, and they're looking at brain MRIs and detecting what is wrong with a person's brain and all. Okay, And other big thing this computer vision is achieving in medical field is vision operated surgeries. Okay, lately we've been seeing a lot of buttonhole surgeries right now. I mean, you know, these days we are not doing open surgeries anymore. We're just putting a hole into the body, sending a camera in there, and using robots. We are precisely doing the operations. Okay, this is also possible due to advancement in computer vision only. And there are various security applications, like just like I told before, home security, biometric, okay, whatever. And just like Sai Satish told before, there are transport applications like automated cars, okay, and traffic analyzing cameras and all. So they can detect people who are not following traffic rules, okay, who are going over speed, who are rash driving, and people wearing people who are not wearing helmet and mask and all, right? So one second, guys. Now we'll just go into some coding. So I'm coding in Python only. This OpenCV is available in different languages. One second. Library. So as you can see, this OpenCV is available in lots of platforms, and it has been developed in C++, as you can see. It also works for Java and Python also, but frankly, I think OpenCV is best done in Python only. I mean, I don't know about C++, I've never done it, but I'm sure Python is way easier than Java and C++. So that's what we're going to do, OpenCV in. So for that, I'm doing this in PyCharm. I'm sure you all know what PyCharm is. If not, it's okay. PyCharm is a Python code editor. Okay, you can just go to jetbrains.com/PyCharm. Okay, just Google search for PyCharm and go to the first link. There you can download PyCharm. There's a professional edition which is paid. I won't recommend it, but there's a community edition with all the features available. Okay, for single developers, right? It's free. You can download it. So after downloading and installing it, you also need Python. So you can just go to python.org. I'm sure at this point you already have all this. I'm just taking 1 or 2 minutes of time to tell people who still don't have. You can go to python.org and go to this downloads and download it for your platform. So mine is Windows. So whatever platform you have, download it for that. Download Python, and then we need an editor. So I'm choosing PyCharm because I like PyCharm, right? We'll just open up PyCharm for now. So you can see I've already written a bit of code. We'll just leave that to the side. So yeah, we'll just get into coding part, right? So to import this OpenCV, we write import.
Yeah, Vishwanath, please increase your font size.
Okay. Is this okay, sir? Should I go higher?
10 more points, please. Actually, YouTube will not allow us to zoom in most of the mobiles. So from tomorrow onwards, just increase your font, okay? Now it's fine.
Okay.
Yeah, you can continue.
Okay. So to start off coding with OpenCV, you have to import this CV2. So if you should have this CV2 module installed into your computer. So if you don't have, don't worry, just go to settings and can go here to projects, go to Python interpreter and download this one. Just add this one, OpenCV Python. You can just click this plus button and search for OpenCV-Python. Okay. So I already have it installed. You can just click this install package to install it. So once you have that installed, you can get into coding with OpenCV. Okay, so I've got an image to do different manipulations on. I'll show you different things that you can do with images. I'll just take this image for now. I have this random Shutterstock image of a portrait. Okay, I just searched for portrait and got this. So we'll just keep using this one for now. So we'll do different things on this image. Okay. So yeah, to start off, the first thing that we want to do with in OpenCV is to display this image, right? Using our code, not just opening it in a image viewer, to view an image through CV2. So we need to have an object for that. We'll take img as a variable name. Okay. There is this function called IMRead. Okay. So all of these functions, you don't have to necessarily remember them. I mean, sure, you can remember by heart a few functions which are like really necessary, like IMRead and all. Okay, you don't have to remember every single one, but you need to remember what functions are there for what purposes. Okay, if you know, like there is this image for there is this image. Sorry, there is this function for turning your for flipping your image in horizontal axis, for flipping your image in y-axis. Okay, and there is this function for turning it into grayscale. Okay, for turning it into black and white image. Okay, you just need to know there is a function for that. You don't need to like exactly remember what the name of the function is. Okay, for starters, IMRead is the function that will read an image from your computer and store it into this variable. Okay, so I just need to define the path for it. So I have this resources folder and I have the image in the resources folder. So I'm just going to take resources slash portrait.jpg. So I now have this image inside this variable. So now I can do whatever I want with this one. So to show the image, okay, to display the image, we have the function IMShow. Okay, so first we need to give a little string for the window name. You'll just understand in a second what window name is. We'll just call it image and the actual image object. So if we run this, as you can see, I mean, you might not have noticed because Zoom doesn't share all the frames. The image just appeared and disappeared within a split second. Okay, why is this happening? Why is this happening? Because these computers have this bad habit of doing everything as fast as possible. So it displayed the image and quickly finish the process also within just a second. But it is of no use if we can't see it for much longer. So if we want to see it for much longer, there is this function called wait key. So this function actually makes the image to stay for a bit. So if we by default use it 0, it will not close until you close it, or you can give any amount of value in milliseconds. So let's say if I gave 2000, the image will, let's give 3000. Okay, if I gave 3000, the image will stay for 3 seconds before disappearing. Okay, so let me run this code again. So you can see the image here, okay, and it quickly closed within 3 seconds. So let me just keep it 0 for now. Now this image will stay forever until I close this one, right? So now you can see what I was doing with the string. So you can see this image here. This is what I was talking when I was telling about the window title. Okay, if I say portrait and run this, so you can see here, this is our portrait. This is our image. So yeah, so what else can we do with this? Let's try making it into a grayscale image. Okay, black and white image. So we have we all know that in our image editor in our phone or in image editor in different social media apps, we have black and white filter, right? So how is it achieved? We'll just see it in a bit. img gray, we'll just take the variable as img gray and cv2.cvt color. CVT color is it's a function that changes from one color coding to another color coding. Okay, there are different types of color codings. So for starters, the main ones are BGR. BGR is nothing but RGB only, red, green, and blue, which is like universal. But in OpenCV, it's just BGR. The order is changed. That's it. And the second one is gray, of course, for grayscale images. And there is this thing called CMYK. I think you've seen it in newspapers and all. Cyan, magenta, yellow. What is K? I don't exactly remember. Let me just Google search for it. CMYK. Okay, key. Right. So this CMYK is there. And there is another one called HSV, hue saturation value. We're not going to discuss this right now. We'll see it another time. I mean, if this format is when you want to play around with it's the hue of the images, right? Okay, so we'll take the image and change it from color BGR to gray. Okay, so this is how you do it. First, you have to give the image object, okay, and then you have to specify a color. This is a constant CVT provides you. So color BGR to gray is one, and there are other things you can see here. Color BGR to RGB, BGR to gray, HLS, HAV. These are different types of image formats. So for now, we'll stick with gray. We'll display that one also. Portrait gray. So IMG gray, we'll use IMG gray. Let me just capitalize this. So if we run this code, you can see here, this is our original portrait, and this is our black and white portrait, grayscale image. Okay, what else can we do? You can also add blur to the images. Okay, img blur equal to cv2 dot. There is this thing called, it just popped up. This is the function Gaussian blur. You can give any image object, we just blur out the gray one. Okay, and you need to give this thing called k size. I don't know if you can see it or not. This is called k size, which is kernel size. So don't worry about this. It's a bit complicated to explain it right now because we don't have much time. So, but just know that you have to give two values to it, okay, in a tuple, and they have to be odd values. Let's say I gave 9 to 9, 9,9. These has to be odd values only, okay, no even values allowed. And then we have to give sigma x, and this is also another thing that we don't really care about. I mean, for now, if you want to go in depth, you do have to care about it. So we have the blur. Okay, let me run the code again. So now you can see the difference between this. So if you can see the difference, it's great. But I don't know if you can see the difference or not, because you're watching this in YouTube. Maybe a low resolution video is coming to you. In that case, I'll just blur it out even more. We'll take some extreme value, like let's take 15 by 15. And now you can see this is this image is way sharper than this image, right? I think you can observe the difference now. So you can blur out the images, and what else do you got? There is this this important thing called canny. Okay. So what is this canny? So canny is to explain it simply, canny just identifies edges. It detects edges in the image, right? So you might have seen this in old movies, or even serials also. Whenever there is whenever they have to threaten you, or give a horror kind of feeling, whenever they are introducing villain, okay, the image, the video will go negative. Okay, right? I hope you understood. So the previous cameras, we have films, right? Those we used to call them negatives. Okay, if you just point it out to light and view them, the image will all be cursed and all. um, you know we'll just understand it a bit. Okay, and I'll also tell you why this is important. So the function is cv2.canny. We'll give the original image. Okay, and we need to give two thresholds. Okay, you'll understand what these thresholds mean. Okay, for now, we'll just take a very small threshold, so that it'll detect every edge. Okay, img canny. Let's run this. Okay, now you can see. Okay, this is the original image, and this is the canny image. I'll just keep them side by side for you to see. Original and the canny. So now you can see it has detected a lot of edges. Okay, so why did I say this is important? Okay, with canny images, you can basically just take shapes of objects. Okay, so from this kind of image, okay, you can hardly you can hardly explain different shapes to a computer. I mean, you can see shapes here, like these two fingers are pointy. Okay, this is a face, these are hair. Okay, and this is a shirt, hands and all. But for you to explain it to a computer, you need to have images like this. So now you can see everything is blacked out. Only the what the borders, okay, the edges are visible. So now if you want to, or let's say, make a document scanner app, okay, you can just take the canny of an image, and you can create a rectangle pattern and match this rectangle pattern with various parts of the image, and find out where this pattern matches, and you can find out where the document is in the image, and then you can scan the document after that, right? This is how OCR readers, different scanners in your mobile are made. For example, cam scanner, which is a famous one, but it's banned now in India. Let's take another, let's say, office lens, okay, etc., like that. So I think you understood what canny is. We can just fiddle with this threshold limits. We'll just keep a bigger threshold. This will only, so the bigger the threshold is, the less edges it will detect. Okay, so now you can see the threshold is much bigger, and it has detected only a very few edges. It is not very, appealing. I mean, it's not actually doing the job, right? So we need to play around with different threshold limits. We'll take 150 here. So now you can see this is much more better. So that is how you add that's how you make a canny image. So we'll go for next, manipulating the dimensions of an image. So right now we've just manipulated the whole image. We've changed it from one color scheme to another color scheme. So we've added blur to it. We've found out different canny images. Okay. Now we'll go to playing around with the dimensions of the image. Okay. Let me remove all this for now. This time we'll take car.png. So this is our image. Okay. We'll see what we can do with that image. So to start, let's go with resize. Okay. Let's say you wanted to resize your image. Okay. So what we can do is we'll just resize this image itself. cv2 dot the function is resize. You have to give the source image, and you have to give it dimensions. Okay, you have to give the dimensions into which you want to turn your image into. So let's say I chose 640 by 480, one of the standard dimensions or ratios. So not much of a difference you won't understand. Let me just show them side by side to you. IMG2, we'll take this as IMG2. Now if we run this, one second, yeah. Now we'll run this. Okay, one image is only showing because I've used the same, I've used the same name. That is why this is just replacing the old image again. Yeah, now you can see that this is our original car and this is our resize. You can see that this is just marginally a little bit bigger. So you can you can also know the dimensions of the image by using this shape. Okay, we'll just stop this for now. Oops. Yeah. So if we run this, you can see this is the dimensions of our image. So this is 462 by 623. And you can also see that there's a 3 here. This 3 just represents, color channels. Okay. So if this was a grayscale image or a black and white image, you will only see 2 channels here. But since this is a color image, and we all know that all images are made with 3 primary colors, red, green, and blue. So you know why red, green, and blue are called the primary colors, right? We can basically make any color with these 3 colors, right? Okay, so these 3 are the red, green, and blue channels of the image. So this is the dimensions of the whole image. Now what I'm doing is I'm just resizing it to 640 by 480. All right. You can make it smaller if you want, 200 by 200. Say, just uncomment this again. So this is the car resize one. You can see it's way smaller. Okay, you can even make it larger. Let's take something really big, 1000 by 1000. This by any means will not improve the quality of the image. The quality is just the same. This is not an AI which will upscale your images automatically. This just makes the image bigger. That's it. The quality is the same. Okay. We'll just go back to 640 by 480. Okay. Let's see what else we can do. We just resize the image. Now we can even crop the image if we want. Okay. So if you want to crop the image, let's take img3 and use the cv2 dot. Sorry, to crop the image, we don't have to use any function. Okay, these images, like let's say, let me just print out the image for you. See, instead of I am sure, I'm just printing the image, right? Okay, we'll just move these two. Okay, now you can see we have a bunch of values, like lots of matrices. Okay, most of the output is hidden here, but you get the point, right? There's a lot of matrices here. Okay, what are these numbers? These numbers are what actually the computer is interpreting them as. Okay, this image object is just a bunch of numbers, a nested list. Okay, three-dimensional nested list, right? But when we are interpreting using it using the IMShow, we can view the actual image. Okay, so to crop the image, since these are just lists, what you can do is you can just do this image equals image. You can index and slice these images just like lists. I hope you all know what slicing and indexing is in Python, right? If not, it's okay. I'll just explain it to you a bit. So we'll do that for the x-axis, and let's take 200 to some 300 for y-axis. So now if we let's do it for image 2. So now you can see this is the resized image. We'll just take a little bigger one. Oh, sorry. Yeah, by the way, I forgot. First, you need to do the height. Okay, this is a little confusing, but the first you need to do is height. Okay, and then you can do width. I know this is a bit confusing because this OpenCV follows a little bit different conventions, just like we did in the default image format. It is BGR and it's not RGB. So everywhere else in the world, the default is RGB, right? But OpenCV uses BGR, and there are some things that not quite perfect with CV2 representation. I mean, it's just their way of doing it, so we cannot say anything. So we'll take 0 to 300 here. So now if we run it, you can see it here. So this is the cropped image. You can basically align this with here. Okay, you can see that is the cropped image. Let me do it for 0 to 300 here and some 100 to 300 here. Yeah, now you can see it. So you can see that it aligns with the image perfectly. So yeah. And another thing with OpenCV is that I wanted to show you how the dimensions work here. So let's just run this for now. So basically, whenever you are working with images, just think of these as 2D figures, okay, an X and Y axis, but there is a little difference here. So generally, when you are working with 2D surfaces, where do you start your X and Y axis? Where do you start your origin? And where do X and Y, positive X and Y axis go? You'll always start at the bottom right, right? Am I correct? You'll always start at the bottom right, and the x-axis goes to right. A positive x-axis goes to right direction, that is east direction, and the positive y-axis goes to north, okay, vertically upwards. But with OpenCV, it's a little bit different. The origin doesn't start at bottom right. Sorry, bottom left. I've been saying bottom right. I'm sorry, bottom left. Instead, it starts in top left. Okay, this is our origin. Okay, and the x-axis as usual goes to right, okay, in the east direction, but the y-axis goes down. So what this means is this is 0 comma 0, okay, this is 460, oh sorry, 640 and 480, okay. In this way the x-axis moves, and in this way the y-axis moves. Okay, I hope you understood that. So that is why yeah, that's how this works. And when you are accessing the image, first you have to get the height and then width. Okay, I know it's a little bit different, but that's just the way it is. Okay, now we have cropped the image, and let's look at one more function here. Not exactly a function, but you can even create your own images. Okay, since these images are essentially what matrices, we can create our own matrix using a uh, module called NumPy. So if you don't know what NumPy is, it's okay. NumPy is basically numerical Python where you can work on with matrices and different sorts of mathematical functions in Python. Okay, NumPy gives you a lot of mathematical and algebraic functions. It's basically made to work with matrices only. So don't worry if you don't know about it. I'm just using this NumPy to create an image, okay, to create a big matrix. So let's take our images img3, okay. I'm just creating an np.zeros, which just basically creates a big matrix full of zeros. Okay, I'm going to give the dimensions to it. Okay, so let's take a 512 by 512 image, and we'll make it 3-dimensional. We'll keep it as colored image, and we need to give a format. This is a format of representing the values. Okay, don't worry about this. So now we have this image 3. So cv2 dot imshow created image comma img3. We'll just comment this out and run this. So now you can see we just have a 512 by 512 blank image. So since this is just all zeros, this is a black image. So now you can do whatever you want in this. Let's say we'll just take this and we can set it to whatever we want. Now if we just want a red image, you can just put 0, 0 and 255. Remember, all the colors go from 0 to 255 only. This is the standard, which is 8-bit color coding. So with 8 bits, you can only count until 256. So 0 to 255 is 256 numbers. Okay. Oh, sorry, I was changing the wrong image. So now this is just a red image here. Okay. And if we wanted, yellow, we can combine green and red to get yellow. Okay, so on and so forth. And you can also create little dimensions in there. Let's say I just want to make a blue rectangle within the black space. Okay, 200 to, let's take 100 to 200, and in the x-axis we'll take 200 to 500. So this just represents a rectangle, and we want a blue rectangle in the whole black image. So you can see we just created that, and you can do various shapes also. And we'll take a we'll take like this, and I'll just give some random numbers. So you can see that we've created this one. Okay, so that is basically how you can do different cropping and resizing and coloring things in NumPy. So I've shown you first image editing, like blurring out, changing the color scale, okay, changing the color encoding, okay, and adding the canny, get to identify patterns. And now playing with the dimensions of the image and adding whatever colors you want. Okay. Yeah, I think that's it for today. You've seen quite a bit of coding in for OpenCV. So now that you've understood like what these functions do, and what you can how different images are represented in Python, I mean in OpenCV, I think you're ready for tomorrow's projects. So tomorrow you'll see different types of projects using this OpenCV. So I hand it over to Sai Satish, sir.
Thank you very much, Vishwanath. So, dear participants, hope you saw the basics of computer vision, especially a library called OpenCV. So we request you to explore some more functions today. And by tomorrow, we are going to see some sort of projects, right? If you want to understand that particular method or library, you have to study these kind of functions itself. Okay, today itself, you have to just explore the things. So meet you tomorrow. Thank you very much. All the best. See you tomorrow. Bye all.